Okay, so without further ado, then let's have a little look at the network infrastructures that we're going to be going through. So we are going to talk a bit more about some network management tools and protocols and what we basically do to manage our networks. We're going to have a bit of a refresh on some of the devices that we see in our network infrastructure, as well as the connections, and we'll talk about some speeds and other items like that. And then we're going to talk about segmenting the networks. Remember, we spoke about VLANs. Did we mention VLANs? I think we kind of touched on them, but we're going to talk about VLANs and other items like that, and a beautiful product, a beautiful thing called DMZ, which is demilitarized zone, which is another zone behind a firewall. And we'll go into all that sort of descriptions as we go along. So the first topic, network management. A network is only really as good as your monitoring, because you can plug all the cables in and you can get everything kind of set up and you can kind of go, right, my network's working fine. But how would you know it's working fine? So we need to make sure we manage that network. So there is a whole load of administration, controlling, monitoring tools that you can use to look at your performance of your network. It can look at the reliability. It can give you assessments on security as well. Okay, and it will do a whole load of activities to make sure your systems are running smoothly and as well as proper as possible. You can do the configuration management, which is another aspect of network management, which involves setting up and maintaining the configurations of network devices. So making sure the key functionality is working okay. And the network management will also allow us to manage faults. So if there is an issue with a piece of equipment, be that a entire piece of hardware, an entire switch, or be that down to an individual port that's having particular problems on a switch, then our network management systems can basically talk about those ideas. And of course, we throw in on that network management security. It's all about keeping our data safe. So security management can look at things such as, are our systems all patched up to date? You know, are our switches and firewalls basically running the latest antivirus software? Okay, and are our basic patches all as they should be? Okay, so it can keep an eye on our security as well. And I think we mentioned in the security, we mentioned things about IDs and HIDs and all that sort of stuff, didn't we? So we mentioned those sort of things that monitor your network traffic and then give you a little alarm if it sees something slightly weird going on. So we can do all that. So there's two main protocols that you use for network management. There's SNMP, which I think is on version 3 nowadays. Okay, so it started with the traditional, as we do. We start with number 1, which is a very simple SNMP, and it stands for Simple Network Managing Protocol. Okay, it's widely used management protocol that allows network administrators to monitor your network devices. Okay, it uses a hierarchical structure of management objects known as Management Information Base, so MIB. We love our acronyms, MIB. Okay, it supports, as I say, variety versions of SNMP, and it will let you monitor all those devices remotely. And the benefit with SNMP is it allows you to also configure those devices. So it's kind of a bit of a two-way configuration conversation that happens with SNMP management. Now, how does that differ from Internet Control Message Protocol, ICMP? Well, ICMP is essentially, as it says on the tin, it's basically the core protocol of IP suite. Okay, this is one of the suites that tends to be used across the globe at the moment. Okay, it's used for network diagnostics and control, so it's better for diagnostics. It does report error messages and provides feedbacks and performs a certain amount of network functions. Okay, and it commonly uses things such as ping to test errors. So you will get a lot of pings going around if you're using ICMPs. Ping's one of the common ones. We use traceroute and other items like that. And it's quite important for some network troubleshooting and assessment. So they kind of both do very similar things. SNMP, I think, allows you to do configuration as well. So what does this sort of network management tend to look like? Well, we will get these presented as dashboards. This is a product called SolarWinds. It's a nice product. There are some problems sometimes with it, but it's generally one of the nicer products out there. So this is an example dashboard, and you can see there, I'm looking at things such as flow rates, I'm looking at performances, I'm looking at patching status. So it gives us all these details, essentially in our lovely single pane of glass, which is what we're after. And that is where really what we're in about. We won't go into a massive amount of depth here, but it's important you realize that there are a lot of different management tools out there that will give you similar dashboards, and they'll give you a similar approach to your network infrastructure. Now, of course, you can monitor one device, you can monitor multiple devices, you can monitor thousands of devices on this. So you can imagine there's obviously some drill downs on some of these menus to let you get more granular. But the general idea of a dashboard is you get a single pane of glass that you look at, and that tells you how healthy you are. If you see anything that's in red or orange or yellow, which tend to be the warning colors, then you should be able to click through onto those and see what is basically giving you problems. You should be able to see things such as items that are unpatched, and you should be able to pull a list of all the items that are unpatched and have a look at those in detail and work out why they haven't been patched and potentially force some patches across. Anyone got any questions about dashboards and those two protocols we use, SNMP and ICMP? Now remember here we were talking about monitoring things such as our switches, our routers, our firewalls. This is all really network protocols that we're managing, network configurations. Has anyone used anything other than SolarWinds for network monitoring? Has anyone got any previous experience with it? Hi, Lass, Alan. How did you find that? Was it really useful, or was it a little bit clunky? It's okay. It's not you're not shouting from the rooftop saying how fantastic it was. It's okay. I mean, most of them, if I'm honest, most of them are fairly unexciting. Okay, we are dealing with network. Some of it is not as exciting as possible. They use it in Amazon. Okay, that's fine. So, but the important thing is that we're getting information. We try and make it as exciting as possible by making our dashboards really attractive. Okay, but generally the information you're getting across isn't isn't thrills and spills, but it is really important details that you're getting across. Just Alan basically used a network monitoring tool before. Okay, that's cool. Okay, well, I did promise you Kahoot, didn't I? So let's dive in with a couple of Kahoot questions then. Are we all ready? I'll give a few latecomers a chance basically to get onto Kahoot before we run the quiz. I think we've got a fair few questions today, so it'd be nice if we all take part and we all work out who's going to get that box of sweeties, box of virtual sweeties at the end of the day, don't we? Let me know if you're having problems, because I'm about to press the start button right after this sip of coffee. If I look a little bit bedraggled today, I've been outside in the sun all day. I've been doing some fencing, which is great fun. Which probably just means I've got loads of splinters on my hands at the moment. Slightly sore. Callie's just joined us. Okay, we're ready then. Okay, let's kick this off then. There you starter for 10, as they say. First question. Multi-select. So select all features of network monitoring. So I checked 13 of you with application management. We don't care about applications. That's the toys that run on the operating system. We don't mind about those. We are literally doing configuration management on the switches and devices. We're doing fault management because we're checking on faults. and we're doing security management. Those are really some of the big three. Applications, I mean, we don't care how Word is performing or something like that. Nothing to do with us. We're interested in only the network end of things. Pat yourself on the back if you got that spot on. Let's see who hit that one straight away. Edward, well done. Sebastian up there. Zachariah as well. Joe's not far behind, and nor is Callie. 2 questions in this starting round. Let's see. True or false? Let's see who nails this one. SolarWinds is the best network management tool available. Split that. I always put false down for that one myself. Yes, there's a multitude of network management tools. How do I know which one's the best? The simple answer is you don't. Simple answer is you don't. There is no rule that simply says this one is the best. SolarWinds is great at doing particular tasks, but other products out there are better at other tasks. So it's kind of horses for courses. If you're running a big network infrastructure, potentially SolarWinds may be a little bit over heavy on some of the networking that it does. So you may want to pick a different product. So it's really a case of fitting your network monitoring tool with the style of networks that you've got and what's critical for your business. If your business isn't heavily security orientated, then perhaps patch management drifts down your priorities. Mind you, it should never do, really. It should be top of the list of everything for security, shouldn't it? But as I say, it really is making sure you pick one that is suitable for you. So I would never, ever say to anyone, any particular product is the best. Let's see, you got that one right. Zachariah, shooting straight to the top. Well done. Okay, so back on with the show then. So a quick recap then. Types of network devices. Okay, these are the typical types of network devices we're going to see. Okay, we'll probably start from the top, shall we? So wireless access point. We know that a wireless access point is very simply that. It allows our wireless devices to connect to our local area network in one form or another. Okay, we know it can use different strengths, so it can use 5 gigahertz, or it can use 2.4 gigahertz, which are different ranges and different speeds. The next one down is a load balancer. Load balancers are fantastic toys. They are great at distributing traffic. And you'll get these when you get larger and larger network infrastructures. If you're working in a local area network just on your own in a small office, you won't see a load balancer because the network connections will manage what they've got without any problems. You don't get any restricted pipelines. But what a load balancer will literally do is a load balancer will literally come in and the traffic will hit the load balancer first. And the load balancer will look around the network and it will go, well, that switch isn't busy. That switch is busy. That switch isn't busy. And it will literally poke the data down to the traffic areas that are light. Because remember, we will have multi-directional traffic in terms of how we can get to particular paths and how we can get to particular resources. And the load balancer's job is simply to sit there and make sure that it's spread nice and evenly like a lovely piece of butter on a bit of toast, rather than all lumpy and horrible at one corner. And that's what your load balancer does. Really great pieces of kit. So we're going to talk about the firewall. So the firewall basically is your network protection. That is your key piece of security on the systems. Okay, we know this is where it enforces policies. We have allow policies and disallow policies, or deny policies, depending on what you want to say. Okay, so it protects us against threats. It has the antivirus, the anti-malware, the DDoS protection should basically be on there, and you might find IDs and HIPs on there as well. Okay, to basically protect your network systems. It normally sits at the edge of what we term as the trusted network. So our local area network is our trusted end, and everything out on the internet is an untrusted network site. And we'll talk about how we use firewalls to create DMZs later on, and we'll discuss what those are. On the left-hand side there, we have the router. Routers basically form the connections, okay? They form connections between your local area networks that are on your trusted network. So we can have multiple local area networks on the trusted side, so inside the firewall, and these are separated by the routers. Routers do a lot of the thinking in terms of what traffic goes to which location. So when a piece of traffic hits the router looks at the IP address and says, I know where that IP address should be routed to, so it passes it to that particular switch that has that particular local area network on. If it doesn't know where it goes, then it goes to the default gateway, which tends to be your firewall, and then it goes out to the internet. Okay, so think of the router as doing exactly what it says on the tin. It routes your traffic. And then we can speak about the switches. So the switch basically connects all the local area network devices together. Okay, it's normally cabled, which is fantastic. You can get PoE switches, which is power over Ethernet. So some of them you don't even need to plug into the power socket. I'm just seeing. I don't have a PoE one to show you, but never mind. So the switches themselves will be anywhere between 8. I've seen the 6-port one. 6, 8, 12, 24, 48 ports you can basically plug into those. Those are network connections you plug in. Okay, and they are literally designed to connect everything up together. You will normally stack these. You will have multiple switches on top of each other. And then right down the bottom, modem. We haven't really discussed modems a lot because they are not massively used. Okay, the difference, what a modem basically does is IP in all our networks are basically what is known as a digital system. So we send loads of ones and zeros down a little pipeline, don't we? A little cable. What a modem basically does is a modem is capable of converting those digital signals into what's known as an analog signal. So analog signals are our fantastic waves. Okay, and that's what the modem's job is basically to do. Is simply to convert those to allow it to transpose across a different form of network. Okay, and that's what the modems are used for. Anyone got any questions about those fundamental devices that we use in our network configurations? I can see Alan typing, that's good. All of the devices will normally be able to report either with SNMP or with the other format. Alan, you're asking what is the exact order of access? Oh, not sure I really understand that question, Alan. No, the slide order isn't anything particular. Are you interested in the access that comes in from the internet and how it's ordered from the internet? Yes, okay. Well, the way that it's ordered from the internet, according to the particular diagrams, is literally your firewall sits on the edge. So the firewall is the piece. We're going to ignore the modem. We're going to ignore the modem for a minute because it confuses life for us. So the firewall sits on the edge. That is your boundary between your trusted network and everything else on the internet. Below the firewall, you will tend to have either a load balancer if you are running heavy traffic, or you'll have a router. So firewall, load balancer, router, then switches. So you'll branch out and you'll have multiple routers and multiple switches depending on how your LAN is basically segmented. Now the modem will normally sit with the firewall, potentially outside of the firewall. Okay, and it's normally provided by your ISP, your internet service provider. Modem, I see Marty basically asked a really good question. Alan, does that answer your question in terms of how it's laid out? I think we've got some layout pictures later on in some of the slides we'll see. Okay, that's fantastic. Okay, where are modems used for usually? Okay, that's a really good question. Modems are Modems are a bit of a dilemma because years and years ago, we used to have to use modems because all the data basically ended up traveling down a telephone line. So when I was a wee lad, the only way we could connect up to the internet was with a modem. Dial up. Thank you very much, Melche. I'm glad someone else remembers it as well. So it's literally done with a modem. So you'd literally connect that to your telephone line, your good old fashioned copper PSTN cable that comes out and runs around the street. So it was a telephone line. Okay, but the telephone line didn't quite like digital signals. So what we had to do is we had to convert our ones and zeros into essentially an analog signal, which is what the PSTN lines understand. Okay, and that was an analog signal. I don't know if you ever remember, if you were old enough, you used to have a special jack. If you once you installed a modem in your house, you used to have a special jack that you used to have to plug all your other telephones into so that your modem wouldn't cut off anyone having a normal telephone conversation when it started up. And they used to make some beautiful squeaky noises and things like that if you ever listened to them. So that's literally where it would sit. Modern days, yes, we can use it. They are becoming more and more prevalent. I've actually got a modem on my system at the moment because that's what I get from my ISP. And what they're doing is they're converting, it's a bit of a cheat really. They're converting a digital signal into an analog signal and then passing that analog signal down a line. And that analog signal goes so far and then it gets converted back into a digital where it hits the fiber network. But for the majority of network infrastructures, that end where we talk about the modem, the other side of the firewall basically being the internet, the untrusted side of the firewall, gets picked up by your ISP, your internet service provider. So it won't be anything you tend to touch, other than when it's not working and they say turn it off and on again. Does that help with everyone basically understanding what the modem basically is used for? Great stuff. That's perfect. Thanks for the questions. Keep these questions coming. This is really interesting when we start talking about those. Oh, no, someone's translating to English. That's fine. Oh, Maljack showing us a dial-up connection there. Danny, make you laugh. When I was a young man and I managed to actually go sailing when I was younger, I was amazed that I could actually connect up my mobile telephone to my laptop and basically dial things up and I could send emails to people from my boat. I was so proud about doing it. Now I'm going to keep in touch with people. God, the old-fashioned dial-up, see. Okay, great stuff. So, oh, look, a couple more Kahoot questions we've got for you all. Okay, let's see who can get Zachariah out of the top. Remember, it's all for fun. Multi-select. Select all the network devices. Ah, there you go. A lot of you got that spot on. So a router and a switch are network devices. Printer connects to a network, but it doesn't do any thinking in terms of traffic for network. Okay, it tends to be known as it tends to be called an endpoint. And the exchanger is just something I made up. Why not? Why not have a made up one in these quizzes? Let's see how that affects the top. Zachariah keeping it going. Sebastian leaping up the way. Well done. So next question then. True or false? With only these cable connections, all these computers can communicate with each other. The connections there are the ones in light blue. You have to ignore the background. This is a bit of a refresh quiz, some of this. False. Who put down false and tell me why they don't think they could connect to each other? The image was not clear. That's probably fair. Yes, we have to focus on the light blue lines, don't we? And the light blue lines are in the background as well. What there was an attempt to show there, which was quite a poor attempt, was that all the devices in the bottom had light blue lines going up to the patch panel, but there was no blue line going to the switch, to any of the switches. But Ronald, because it was not connected to the switch. Top work, Ronald. Thank you very much. So remember, what does our patch panel actually do? Anyone fancy answering that in the live chat for me? See a few of you type in. Just extending the switch ports. It's a fairly decent answer, Alan. Yes, definitely getting there for sure. Connects devices to the network. No, it definitely does not connect devices to the network. Organizing cables. Majelch. Terrible pronunciation. Nardi says sharing. Helps with the terminals of cabling. All right, Alan's good. All right, hold on. I'm just quickly looking for a couple of network cables. Right. This is a on the fly demos we do today. This is literally all a patch panel does. That's it. You got one cable comes in the back to the patch panel, and you got one cable you plug in the front. It's simply a straight through cable connection. There's no brains, there's no connections between anything else in the system. It's just a straight through connection. It's only when this cable ends up getting plugged into the switch that we then make any form of connection at all from that system. Does that make more sense? It's a passive device. It very much is a passive device. Yeah, but it's only connecting one cable to one cable. It's not connecting anything else to anything else. One cable to one cable. Which side of the switch now? Does that make sense? Fantastic. That's good. Okay then. Now I'm going to apologize straight away. I know I've seen the next slide. So think of it as the blue lines. They're quite light, but try and focus on the blue lines when those ones are done. Ah, Zachariah's on fire. No one's going to catch you today. True or false? All these computers can talk to each other. Those of you already answered, I'm going to ask you why you think they can. True. Wow, 16 if you got it right. One of you might have just been a little bit keen to try and type the answer for the fastest fingers. So why do we think all those computers could talk to each other? They're on the same network, all connected to the switch. Now Jet wins a bowl of sweeties. Same subnets, okay, as well. So yes, there is a physical cable connection. Fantastic. And they're all on the same subnet. They're all 192.168.50 as the subnet. Fantastic. Everyone understand that? Thumbs up if you understand that concept. Oh, thank you, Alan. Good. If some of those had different IP addresses, such as 10.10.1, then that machine wouldn't be able to talk to those on 192.168.50. So they wouldn't be able to communicate in those cases. Well done. Okay, next question. Let's see who basically got that. Smash that in. Sebastian's up there. Kaylee, Gabino basically jumping up. Zachariah on a 5 streak answer. Let's see what we can do here. True or false? All these computers can communicate with each other. Majel, don't type it in live chat. That's giving it away. and you're not able to get onto Slack. False. Sorry. Feel like you'd have a fair few sweeties at the moment, wouldn't you? False. So those computers can't talk to each other. Right, who's going to tell me the reason they couldn't all talk to each other? Alan basically comes in not on the same subnet. Right, he basically comes in as well. Different IP addresses. Yeah. Seth, different subnets. Yes, because they're on different subnets. The switch itself, remember, will deal with the subnets, but it will not allow communication between different subnets. If we wanted to communicate between different subnets, we'd have to put in a router, and the router would say that subnet can talk to that subnet. Subnet A can talk to subnet B, and we'll chat about that in a later thing. Well done for 30 of you that smashed that one in. All the cables were connected correctly as well. Okay, 6. 2 more questions in this little section. Up 5 places for Kablan. Well done. Let's see if we can smash you into this top 5. True or false? All these computers can communicate with each other. Majelch connected to a router. Majelch has gone for a yes. True and false. Okay. Why do we think there's such a split between true and false here? Can anyone tell me a reason? Alan, there's a bucket of sweets coming your direction there. We don't know the configuration of the router. So we put a router in the top. So we've got 2 separate subnets connecting to the switch. So physically, there's a connection between them and a connection to the router. But it's up to the configuration of the router to say subnet A can talk to subnet B. So all of you are right, essentially, on that one. Although I put true down. Because essentially I would have configured the router so they can chat to each other. So Seth basically nails it there. There's some sweets coming your direction as well. Routers can connect 2 different subnets because they route the traffic. Wow, look at that. It's routers, isn't it fun? I love it when they call things in sensible names, really, in IT. Right, last question for this particular batch. I gave no points for that one because it could be a true or false. So which of these protects a network from cyber threats? Yes, basically the firewall basically protects us from cyber threats. That's its job. Well done, everyone. Let's see how that leaves the points. Regex basically says firewall in a router. When we deal with pure network science, we basically look at routers being routers. Now, I know full well we are going to talk about SOHO devices later, which are the small office, home office devices, which all of you have basically in your house. That device acts as a router, a firewall, a switch. So it acts as all those things. Okay, so we do kind of cheat a little bit. But when we talk about in business environments, the router does routing, it doesn't do firewalls. Good, look at that. Okay, so Zachariah basically the top. Sebastian's not far behind. Oh, there's a whole load of you around the 4,000 mark, isn't there? Good stuff. Anyone got any questions about those sort of things that we've just kind of had a chat about in terms of the connection? We all feel a little bit more confident now about the subnets. Thumbs up if you feel a little bit more confident about what can talk to what. Great stuff. Always remember the first rule. First rule is if there is no physical network cable between them, as in if they're air gapped, we're parking Wi-Fi on the side. If they're air gapped, there's no physical connection between 2 systems. they will not be able to talk to each other. Don't care what you put in your router and your firewall. If there's no way for an electrical pulse to travel down the line to them, then they are not going to work. That's the first rule of thumb, basically. Great stuff. Well done, people. I really enjoyed that, actually. God, we should do more Kahoot, shouldn't we? Okay, so let's talk about service providers then. So service providers, we can get our ISP, internet service providers, to provide us different styles of connections. Okay, first one at the top is cable. So it's a high-speed data transmission with ample bandwidth, multiple connections. It's about 219 megabits per second up and about 24 megabits per second. Yeah, other way around. 219 megabits per second up. Sorry, I'm going to start that again. Sometimes I just can't read my slides. 290 megabits per second down and 24 megabits up. That's because mostly traffic is basically prioritized for coming down to you. DSL is stable but slower. Again, with DSL, you only were allowed to get 10 megabits per second. DSL was basically running on the old-fashioned copper cables that we used to have. And then, of course, we've got the beautiful fiber. Put your hand up if you've got fiber in your property. Pinter, Allen, Mardy, yeah. Well, now fiber is becoming much more popular. It's becoming much more available worldwide. I know in the UK, the government basically had a push to basically make sure that every house was able to access fiber. And for some unknown reason, they started it all the way down in Cornwall, which for those of you who don't know England, it's that sticky out boot bit all the way over to the west-hand side of the UK. Gabits pays 5G, but I have 3G. Yes. So, yes. And then, of course, we can basically do things on our mobile data signals, which is the 3G, 4G, 5G. So 5G, you can potentially get up to 300 megabits per second. Well, that's fairly decent, isn't it? That's pretty acceptable if you are, if you're streaming some videos, as soon as you get 4 or 5 people, then streaming videos is quite challenging if you're streaming slightly different videos. Now, what is very common is when we were opening offices, when we open brand new offices, getting a fiber installed, a business fiber line installed into a new location could actually take up to about 60 days, depending on your ISP. They were a nightmare to do it. You'd have to book it in. There'd be a full inspection for health and safety. The health and safety report would have to be read by someone. They'd have to verify it. Then they'd have to send the engineer out to blow the fiber cable in the right location. Then they'd have to send an engineer out with the hardware, basically, to install all the fiber onto the right kit. Then they'd have to configure it. So literally 60 days was what the average lead time was. So if you're in a fast moving company, kind of going, yep, we want to open small office here, small office here, small office there. 5G networking is great. We used to actually send out a router with 5G networking to the office, and they used to get that connected and up and running while we were waiting for the fiber basically to turn up. And indeed, now with 5G going up to about 300 megabits per second, in large towns and places like that, it's quite often used essentially as a backup line. So they'll have fiber as a primary and then 5G as a backup line. And that means if someone cuts through your cables, then yeah, you just drop down to 300 megabits per second, which in most cases is enough to run a small office without too many people crying too much over it. Any questions about service providers and the cabling that they basically use? Gabitsu, do you use the 5G because you are living in the middle of nowhere? See several people typing. Yes, fair enough. I've got a friend who lives in the middle of France, or spends at least 6 months in the middle of France. And he has only just got installed fiber. And bearing in mind, we are at the stage now where fiber is very common. bearing in mind the village, well, they call it a village. It's not really a village he lives in. There's three houses. Okay, let's put it like that. There are three houses where he lives. There's a guy who does foie gras, a farm guy, and there's a guy who hunts with wild boars, or hunts wild boars with his dog packs, and then there's my mate Steve who runs triathlon camps. So they've got three of them out there, and they've now got fibre to their locations. I don't think the other two care, but Steve did. Grosnach in Germany. I have no idea where it is. I hold my hand up. My geography's sort of okay. No idea where that is in Germany, but hopefully at one point they will get you fibre. Are those underwater internet cable fiber optics? Most of the ones they install are fiber optics in the modern systems. Yes, the old ones did used to be big copper cables. But you've watched them roll out, and you've watched them roll out bundles of cables that are like that thick. And indeed, we did see the Amazon rollout, didn't we? We saw the Amazon video where it showed them basically rolling off of the back of a tugboat, wasn't it? It's amazing that those cables actually go the whole way across the Atlantic, isn't it? There is a transatlantic cable that goes all the way across. That's interesting bits. It sounds like you do live in the middle of nowhere. 30 kilometers from here, where I go to my sister's house, I don't even have a phone signal. I mean, that's fair enough. I mean, my dad lives in North Africa, and I don't get a mobile phone signal when I go to his house, and he's in the middle of a town. And this is the Romanian internet. Cost could be enormous. Yes, definitely the cost could be enormous. Okay, so any other questions about service providers and the network connections? I think we're pretty good, aren't we? So we said we talk about segmentation, didn't we? Segmentation of networks. Okay, it's essential. It's an essential practice that we segment networks because we don't want different parts of our networks talking to each other. We want security and security and even more security where possible. Okay, it's simpler and simpler now to segment our networks with greater control. So it reduces our vulnerabilities, okay, and mitigates any potential impact of security incidents. So there's three ways we can basically segment our networks. The one on the right we know, okay, with subnet masks. Okay, we know that if we're on different subnet masks, then we cannot talk to each other. And we also talked about the CIDR. Remember that the /24 or /23 that then allows us to kind of expand that subnet, so we can then expand the number of devices that we see on our subnet mask. VLANs on the left-hand side is a virtual local area network. Okay, it allows us to segment things even more because it allows us to control who talks to what on which particular VLANs. So the maximum number of VLANs on an Ethernet network, this is a regular network we have, is 4,094. Okay, it's normally provided by the 12-bit VID field. Okay, so that's the values you can basically have. And then we have what's known as DMZs. DMZs are demilitarized zones. Fantastic. I don't know who thought that name up, but definitely they need a gold star for that one. DMZs are created by firewalls. Okay, we've already said, where does our firewall sit? Our firewall sits between, at the very edge of our trusted network and the untrusted network that's the internet. Okay, well, what about if I tuck a firewall inside my network? Well, I can create a DMZ because again, I've got another barrier that basically allows us to hold things back. Okay, this massively increases my security because now to get to that location, you've got to pass through two firewalls, two sets of rules that are trying to tell you no, you can't get anywhere. And it definitely allows you to hide devices. So you can see here that network segmentation is basically happening in different locations here. So the user segment, customer terminals, like, that's fairly open, that's out there. And then we have communication with our ground segment. So our ground segment, yes, we protect with a firewall, it falls into one particular LAN. But then we've got the pre-launch area. So pre-launch, we want no one to get to. So that's where we put a DMZ in. So we put a firewall at the edge of that and say, okay, this is another secret network area that is only accessible by something we really give access to. And that further allows us to really segment things up. I can see Ron L's typing there. I think we're going to finish off the network segmenting section and then we might have a little break. Yes, Ronell, exactly. Every time someone says DMZ, I'm kind of thinking, oh, I've seen those Vietnam films and things like that, haven't they? Where they talk about demilitarized zones and all that sort of protection, isn't it? Alan, very well. Good, great summary from Alan there. So a DMZ is a firewall protected zone inside our network. Yes, and companies will have this. NATS basically had several of these because they wanted to separate what they term as the non-safety network, which is where people like me, trainers, and other people basically plug into, and they do all their bits and pieces, accessing systems that aren't live, and the safety network, which is literally the bits and pieces that stop the planes bumping together, all the servers that are running that are keeping the spacing correct and managing all the navigation. So they are separated in separate DMZs for security purposes, separated by very complex and powerful firewalls. Oh, that's where you start getting fun, isn't it? Generally, no. I would not normally allow this on any of my networks. And the whole reason behind it is, hold on, I've got 4,000 different IP addresses I can have. Now, I take it when you say, can two different VLANs have the same internal IP address? Definitely not on your local area network. But if you expand it out more, then potentially yes. But the problems you have with that is really with the routing of it, isn't it? So if you begin to start routing, which route does it take to that particular IP address? Because you've got two of them, so it doesn't know which way to go. So as you've got 4,000 different VLANs you can have, let's stick to slightly different IP addresses on those. In theory, Alan, if you've DMZ'd it, then you have got separate networks. So you could have the same IP address on your internal DMZ as you have on your general DMZ. I would definitely never, ever recommend it. Only because it gives you a horrible headache anyway, in terms of what basically goes where. And you have to manage the routing traffic specifically. And then it does get very, very horrible. Good question, though. Do keep those questions coming. So let's have a look at network segmentation in a word. You can see in here, I have got 3 subnets. So essentially 3 VLANs. I've got VLAN 10, VLAN 20, and a separate VLAN 1, basically on the right-hand side there. My local area networks have switches in there. So the switches are intelligent enough to pass the traffic between the network. So any red item is basically on VLAN 10. Most of the blue items, the light blue items, are basically on VLAN 20, and the dark black icon, well, black icons are on VLAN 1. So on my left-hand side, my networks can chat to each other with the switches as long as the switches allow the VLAN. Remember, switches are now intelligent enough to share VLANs. So we can have VLANs communicating to itself. Well, the router is the one that does a lot of the control. So the router will be the one that controls the traffic and tells and agrees that VLAN 10 and VLAN 20 can talk to VLAN 1 or not. And indeed, your router will control that traffic to a massive extent. I think some of the point here is really pointing out that the physical connection, physical cable connection, does not mean you're basically going to get a connection to those particular items. The switches run on layer 3, which is IP addressing, so they can understand VLANs. So yes, so the switch VLAN checks before the IP. Does that make sense? So I think what I'm really saying is that the switch understands about IP addressing and routing, and it will understand what the VLANs are because it knows about IP traffic, and it will be able to say, I should be able to let VLAN 10 talk to VLAN 20. And that way you would configure the switch to do so. The old-fashioned switches years ago weren't that intelligent, and it had to go via a router, so it had to bounce out to the router first, and the router then had to make a decision as to whether or not it would pass it back to the switch on the relevant switch port for that other VLAN. Modern ones are clever enough to sort it out now. See a couple of you typing there. So I think we're going to pop into a break in a second once we've finished answering these questions. We'll give you 10 minutes. That's right, email check. So you can see that switches. Normally I mute my phone. So normally switches. So yes, so switches 1 and 2 can basically have communication. They understand the VLANs. They know what they're doing. But any device that needs to speak to something on switch 3 has to go out via the router. So the router controls all that traffic and will agree to pass that traffic across, or not, as the case may be. Good. Any other questions before we take a quick, let's have a 10-minute break, shall we? Good stuff. Okay, I hope we've got some great sounds to play. Looking forward to it. Well, on a Friday, it was a shame just to kill that music, really, wasn't it? That was very mellow. Well, I hope you're all right, and you've all basically come back from your quick comfort break or your apple or coffee. We see a thumbs up for everyone who can see the network topologies. So Nobu, fastest fingers first. Mardi, Alim, Edward, Peter, Sebastian, Ethan, Ronald. Okay. So let's kick it on then. So network topologies. Yes, we build our networks in different shapes and files and formats, okay? These are a multitude of these. Think of each one of these blue dots either as an individual local area network in a building, or you can think of them as a wide area network. So each of the blue dots is a local area network that you are combining into a wide area network with the blue lines as being their main connection paths. So if we take it from the left, okay, this is as it looks, it's a star topology. Okay, the benefit of a star topology is you have a central managed communication system that sits in the middle. This could be your head office, and all basically the other offices talk to the head office, and if they want to talk to another one of the sub offices, their data communication goes through your head office and out the other side. Okay, this is great. It gets you lots of control because you control everything in the middle of the office. Also means that everything is only essentially 2 hops away. So 1 hop into the middle, 1 hop to the outside. Then we have the bus technology. Okay, bus is very simply a line of technology. Okay, you can see in a bus technology, we simply move down the line. There is no central form of communication hub, so there's no central hub. So the data that gets transferred, say, for example, the office on the left, office number 1, wanted to speak to office number 5 on the right-hand side, that data would have to communicate through all those individual LANs. So it'd have to do 4 hops to basically get to the end of it. Then we have what is a popular format, which is the ring technology. Okay, although there is no central data location that you basically managing everything from, you still have a form of redundancy. You can see with the bus technology, if office number 3 goes down, well, 5 and 1 can't talk to each other, okay, which is a big issue. Whereas with the ring technology, if one of these offices go down, well, the traffic just simply goes the other way. So it just pops around the circle in the other direction instead of taking potentially what might have been a more direct route to one of the offices. And then we have one that potentially we should all be fairly familiar with, which is sort of a mesh technology. Now, a mesh technology is literally like the internet. The internet is built in a mesh technology. Okay, because this basically means that every device has multiple paths out of its location. So if I lose one of those particular data points, well, no one cares because it just goes through another data point to the right location. And indeed, this gives us a massive amount of redundancy because I can lose 2 to 3 of these data points. As long as there's still a path, and there always should be a path through to the other end, yes, we can still basically get it across. So you've got multiple redundancies. Now, of course, you can see things, technology such as the star technology, we've got one connection for each new office. With the bus technology, again, we've got one connection for each office. With the ring technology, oh, we've got 2 connections for each office. So we are sort of doubling up on the connections, which makes it more expensive. And with the mesh technology, well, I can have 3, 4, 5 different connections for each one of my offices. Beautiful redundant paths, absolutely fantastic. But I'm paying 3, 4, 5 times the amount each time I basically put another office in. So we'll kind of go through those in just a little bit more detail. So mesh network, as I said, each node communicates directly with each other node. So this eliminates the point of a central access point. So let's go through some of the pros and cons of those. I kind of went through them anyway. So Star Network is easy to set up because you've got a central management system. Well, you just do it from there. So you control everything from there, really easy to manage. But it depends on that central hub. If that central hub goes up in smoke, you're not playing ball there, are you? Bus technology, we said, is simple, very suitable for small networks, easy to add and remove devices or network points, but you've got single points of failure. The ring, basically devices have equal access. There's no central point of failure. If we lose one, we simply go the other way around the traffic. Sometimes it can be difficult to troubleshoot because you don't know which way round the traffic is going. If you get some device trouble failure, how do you point out where that device has basically fallen over? So it is interesting in its limited scalability because, of course, you have to break a connection to put a brand new device into there, a brand new local area network into it. And then the mesh, as I said, it's really complex, very entertaining to try and manage because of the different routes and paths that can be taken for traffic, but fantastic redundancy. Any questions about some of the network topology that we've got? Great. So I think we're going to drop in for a continuation of the Kahoot. So we've got a few more Kahoot questions. Let's have a little look then. So for our quiz, a DMZ. What is a DMZ? Good. So it is designed basically to provide a little buffer between the external and internal networking capabilities. I like the green option. Prevents Apple from taking over the world. Oh, it's not had a big change on the leaderboard there. Max has basically won in. Well done, Max. Keep that going. VLANs need to be on different switches for security. Does a VLAN need to be on a different switch? These fastest fingers on that one. False. We can have multiple VLANs on exactly the same switch. If I've got a 24-port switch, sure, I can have 10 different VLANs running on that switch. Because the VLAN basically sorts out the security with the IP addressing. At our level 3, I think a lot of people call it. But we use IPs. See how that affects it. Zachariah has been overtaken there by Gabino and Sebastian. Well done. I knew we'd catch him. Let's see if you can get back in there. With a star network, you are never more than 2 hops away from your destination. Oh, you see a lot of you rapidly coming in there now. True. Remember with the star network, we have a central hub and then all the other ones outside. So you're always just 2 hops away because you go to the central hub, then out to where your destination is. So you're only ever 2 hops away from your destination. Max has pushed up. Well done. And Alan, well done. Edward is the highest climber on there. What are we on? 11? Question 11. Mesh topology provides the best redundancy. Oh, look, how many of you smashed that straight away? I hope you've all just clicked the right one and you're not just randomly picking anything. Let's see if that works when we come to the end, won't we? Gabitso, I'm sorry, you've got a bit of lag. True. Okay, so mesh topology provides multiple layers of redundancy protection. Oh. Left click instead of right click. That's the benefit of a mouse pad, isn't it? Boom, I've got networking covered now. So on a scale of 1 to 5, strongly agree. 5 if you agree that you've got networking covered. 1 if you still no idea about networking. I'll see if I can write one more question for you. Let's see. I can't actually, but it's a false promise, but the thought was there. Wow, beautiful. So over 50% of you strongly agree that you've got networking covered now. Good. I'm glad we're making sense of it. And like I said, we do it in three sort of lectures initially, and we do a troubleshooting one at another point. But yes, you can see how much fun some of the networking can be. Let's have a look at the podium for this. We're going to hit the podium first. Alan comes in 3rd place. Well done. Max, a late spurt from Max, I believe, coming in 2nd. Who's in 1st? Sebastian. Well done, everybody. That was really good. Zachariah, I bet you felt robbed. You were romping away with it to start with. Well done. Pat on the back for everyone for taking part in that. That was a really good Kahoot quiz. I do enjoy those. Right, but it's not home time yet. We've got to cover some advanced networking technology. Okay, we kind of covered the stuff that that deals with VLANs, physical switches, and all that end of things. Now, when we move more and more into the bigger network infrastructures, we move into further technology based. So SD-WAN is really a software defined wide area network. Okay, this is where your software is basically managing your network protocols and performing essentially what is a wide area network. SD-LAN is exactly the same. So it's software defined networks, but it's a local area network. So basically on your local area networks. And SDN, which is a network architectural approach that separates control from the data planes, enabling central control and management through software-based controllers. So what this really means is that we are taking away a lot of the thinking behind it. Okay, so we will simply install switches after switches, routers after routers, etc., and we'll put that in, and then we hand over the control to the software. So we will simply go to our software to basically define our local area network structure, to define the routes, to define everything. So we don't have to go to a device to configure it. We will simply look at our software, and our software will say, well, I want a new VLAN for these devices. I'll put them on new VLAN. I won't care which port they're plugged in. I won't care which switch they're plugged into because my software will know all that. My software will sort all that piece out. And I just simply go device 1, 2, 3, 4, put them into their VLAN. Bang, off it goes. It makes the changes for it. And it's all software defined. So it allows really your administrators to make dramatical configuration change and allocate network resources and prioritize traffic and apply security policies without having to think of, oh, I'm going to have to make that change to that Cisco router. Well, we don't care it's a Cisco router. Our software takes care of it. It does all the hard work in terms of the background. You just simply go, well, I want this device to talk to that device. And the software will go, okay, I've done that for you. I've made the changes to the routes. I've made the changes to any VLANs that are needed. Bam, off you go. Alan, you say pretty complex. I think sometimes it takes away a lot of the complexity from you. If you're managing a multi-site infrastructure and you kind of install a brand new office and you kind of go, right, okay, so I've now got to configure not only the switches, the routers, the firewalls, and everything to allow that particular part of the office to talk to my main database and to work on our ticketing system and to connect to this particular architecture that I need them to deal with. Doing that physically, you have to basically log on to each individual route, each individual switch. If you've got multi-layered switches in there, well, you've got to configure each one individually. If you've got multi-layered switches, multi-layered routers in there, you've got to basically do that. If you've got redundancy control in that, you have to then go and configure all those, and you have to do it on the office end, so the small office end, as well as in your big centrally managed system end, as well as on the end if you've got a DMZ or anything like that. Whereas the software defined, basically you can come into this nice little application and you can go, Bob, I want that to connect to that. And you click the button and it goes, yeah, I've done that for you now. So you can make big sweeping changes really simply with a software defined LAN or WAN. In fact, I think Amazon, I'm gonna kind of go out on a limb here. The Amazon Web Services, AWS, the networking that you see within Amazon Web Services is all software defined. So I don't even think you need to consider IP addressing when you provision your systems up there. You just define which network they belong to. So you give it a network name, you don't care what IP address, you don't know about the 192.168.50. Whatever it is, or the IPv6. Thank God for IPv6. So you don't have to care about that for IPv6. You can just use proper names. You can say, well, that's my LAN 1 and that's my LAN 2 and that's my accountancy LAN. And you kind of go, right, okay, well, I want my accountancy LAN to talk to my LAN 1. So you don't have to configure the routes that basically go through or anything like that. You just allow communications on particular ports. So it is very nice when you get your head around it. It takes away all that thinking about, oh, that IP address and that subnet mask. But that is obviously done on the virtual environments, which is the AWS system. Any questions about software LAN? SD-LANs, SD-WANs, or SDNs? Yeah, so it kind of dreams onto, the modern infrastructure. So advancing on our networks basically makes our network the topology higher speeds. We've got more speeds, we've got fiber optics. Excuse me. So we've got Wi-Fi 6, which is faster, more compatible, more reliable data transfers. Okay, we've got enhanced scalability. So our modern office and networks basically allow us to make things bigger and better. We've got software-defined networks, and we've got network functional virtualization, which is dynamic allocations and provisions of network resources. So we can dynamically control things. Along with this, obviously falls into the ever increasing improved security because we need more and more security. So software design networks allow us to add security on these things. And of course, when we move towards the modern infrastructure, we have an easier centrally managed system because we are now looking at central management. If we're defining it with software, well, it's really easy for software to produce reports on where the traffic is going, where the bottlenecks are, and how we can ease the bottlenecks. And we can look at the holistic view of things in a really bird's eye view, and we can drill down really easy into what we're doing instead of having to draw things on a piece of paper that basically, I'm going to draw my network map now. Gone are the days where we have to keep it on an Excel sheet and try to work out which IP addresses we've used. And the modern infrastructure will, of course, support for new emerging technology when it comes in. So the Internet of Things is obviously a buzzword that's been around for years. But IoT things, cloud computing, edge computing, and virtualizations basically help with our modern infrastructure. So we're not actually going to do this discussion question because we have a real treat for you now because Ragib is going to give you a quick demo on his Wi-Fi router and his router system. So what he's actually using is what we call a Soho device. So that is a small home office device, which is in fact probably pretty much what you've all got at home. Right, Gib, you good if I hand it over to you? Fantastic. I'll take a back seat. As usual, 5 questions in. Have a great chat and I'll speak to you in a minute.
Hello, everybody. I'll just share some images in live chat. So in my house, I have like 2 different network devices. So one of them is a Wi-Fi access point. So its main job is to send out signals to my phones, laptops, tablets that can connect to the internet without Wi-Fi. So that is basically what provides the Wi-Fi. So the one that is cylindrical, so that provides the Wi-Fi, and the other image that you see, it's in my garage, that is my router. So that is the traffic manager. So it connects to all the devices in my home to the internet, and it makes sure that the data goes to the right place, right? So yeah, so in many homes you will just find one box from your ISP. That's because most homes, the routers today have built-in Wi-Fi's. This means that one device acts as both the router and the access point, making it simple and set up to use. But in like larger homes, if it's like multi-floors, you will find like a router and an access point separately to make sure that the Wi-Fi reaches everywhere. So you might have one box. My previous ISP had one box, which was like a both, which does everything for me. But now this one it's 2. Okay, so one is the router and one is basically that provides Wi-Fi throughout the house. And I think I can add more access points. So this one is in the 2nd floor. So if I want, I can add another one in the 1st floor, another one on the 3rd floor if I need it. So yeah, so there is that. So what I will do now is share my screen, and we can take a look at some of the options that you might have. You might have similar options in your router settings, but I would say don't try this at home if you are not familiar with this. That's why I'm showing you. So if I break something, it's my responsibility. So I would say don't.
Who's going to take over if you disconnect yourself?
Yeah, yeah. There's that.
Thank you.
There's absolutely that. Okay, so as you can see, so normally you have a reserved IP address that you use to log into your router. So I have two because I have two devices. So one is for the Wi-Fi, some Wi-Fi settings, and this is mainly all my router settings are in here. So I'm just gonna log in to my router settings and just walk you guys through some settings that are useful or that what we have covered in class. So this is like a visual that shows that the router is connected to an access point, and there's like 36 devices. That's a lot of devices that are connected right now. So first thing I want to show you guys are the DCHP settings. So this we can find it under network. Can you guys see my screen okay? Is it too big, too small, or can I get a thumbs up if you guys can see my screen? Good. Okay. Bit too big. Is that for everybody or? Okay. Is this better, Ellen, or? Okay. Is it good for everybody else? Sorry, I just zoomed out a little bit so you guys can see all the options. Okay, and if you can use the zoom functionality within Zoom as well. So if you want to zoom in however you want. Okay, so this is basically where you can tweak some of your DCHP settings, right? So this is basically everything to do with your LAN. So the first thing that you see, the IP address. So this number is the IP address of your router itself, right? On your local network. So as you can see, this is the same address that I'm using to log in. So it's like a main entrance to your house, right? So when you want to talk to the internet, all your devices go through this door. So often to log into your router settings, you will type an IP address like 192.168.1.1, or for my case, it's 192.168.1.254 in my web browser, and then I can have access to my settings. IP subnet mask, this is a bit more technical, but think of it as the subnet mask tells the router and other devices which part of the IP address refers to the network and which part refers to a specific device. So what it basically does, it helps them understand if a device is local, which is basically a device on your home network, or is it a remote device, which is out on the internet. So 255.255.255.0 mask usually means all your devices are starting with a 192.168.1. So basically they're on the same local network. Then we can look at the IP address pool. So this is where the DHCP host decides which IP addresses it will hand out to your devices, right? So like we talked about in class, like your router automatically handles this for you. So the start IP is basically, this is the first IP address that your router will give out to a device that connects to your Wi-Fi. So your first phone might be 192.168.1.64, and the next one would be the same .65, and so on, if that makes sense. The reason that you might ask, why does it start at .64? Why doesn't it start like after 1? What it means that the router has configured to hand out the addresses from .64. They're often reserved by the router manufacturer, or could be left open for you for some manual assignments of some special devices, right? So if you want to assign, let's say, a printer that you want to assign it to a fixed IP address, you want to assign it to something the same IP .10. So that's why they leave out a little bit of space where it starts from. The end IP, this is the last IP address that your router will give out. So your devices will get an address of somewhere between 64 and 253. Yeah, and let me see. Yeah, if you have any questions, you can drop them in the live chat. I will try to address them, or I will address them once I'm done. So domain name, usually it's blank for like a home network. It's for specifically like a local domain name for your internal network. You don't often see this being used. Think of it as like a nickname for your network. For example, if you set it to, let's say, myhome.local or something like that. All right, so if you set it to like something like this, you might then be able to type like myprinter.mylocal.myhome.local instead of an IP address. So your devices within your house will have like a domain system. I mean, it's more common in like larger businesses, but not in homes. Log me out. Then we can talk about the DNS server. So again, we know what the DNS is, the domain name system. So think of it as an internet phone book. When you type google.com into your browser, DNS server translates that into like a human readable name. So if you leave this blank, your router usually uses the DNS server provided by your ISP, but you can use other ones. Just make sure that this is just for your LAN. Okay, so a WAN DNS server is different from a LAN. This is for devices on your network. This controls what DNS settings your devices will receive via DHCP. Okay. Next, we have the lease time. Lease is basically what it sounds like. It's like when your device gets an IP address from your router, it leases that IP for a certain amount of time. So one day is generally a common setting, right? It means that your phone gets to keep that IP address for a day. If your phone gets disconnected and then it gets reconnected within that same day, you will get that IP address back. If it's disconnected for a long time, then the lease time, and then in between you connect another device, then that IP address will be assigned to that other device, and then you will get a new one for the phone. So that's basically what it means in terms of lease. So these are our LAN settings. So we can take a look at some of the WAN settings. So there are certain things that are here, but I want to specifically talk about the WAN DNS settings. So again, currently it's set to yes, which is default on most home routers. This basically means that our router will automatically get the DNS server address from your internet provider. So this is usually the easiest and the most common option. So your ISP's DNS servers are generally reliable and works well within your network. So basically you're using your ISP's phone book, right? So when you pass a website, the ISP direct you to that website server's IP address. So if I want, I can actually set my own servers. So server one, this is where you put the IP address of your primary DNS. So if something happens, then it will go to server two. So there are some companies that offer free public DNS services that you can use instead of your ISPs. Some of the popular ones are like Google Public DNS. I believe it's 8.8.8, or the secondary one is 8.8.44, something like that. There's Cloudflare's DNS, which is 1.1.1.1. There's OpenDNS, which is something. And you might ask, like, why would I use a DNS service instead of like, my ISP? Some of these public DNS providers claim that they offer better privacy. Sometimes they say they have built-in security measures that are better than your ISP. Occasionally, some DNS servers might be faster than another, right? You might have your own DNS servers and you can block certain websites or certain type of websites if you want. So that's one of the reasons that you might use a different DNS settings rather than what's provided through ISP. Next, let's take a look at some of the firewall settings. So I have two firewall settings. One is IPv4 and IPv6. We talked about DMZ today. So here is something you can set it up here. We can actually add some rules here as well. In terms of currently it's maximum to 10. So for example, here I can so this page would let us control what kind of internet traffic is allowed or blocked on our network, right? For example, in service name, you would put a label, right, to remind us what kind of rule this is. Let's say you want to block gaming traffic. I don't know why would you, but let's say you want to do that, you would put something like that here. In terms of type, sometimes you can pick a common service from a list. My one, I think you have to type it. So if it's like HTTP or FTP, or you can leave this as blank. So it will block all types of services. Then you have sources. So here you would name a device, like which device you want to block. I believe you can keep it empty for all devices. I could be wrong. Or you can pick an existing device from my network and I can block that. And then protocols. So TCP is the most common. So this is usually for any kind of web traffic. So websites and emails. UDPs are mostly for, like we talked about, David talked about it. So UDP would be more for like streaming and gaming. The source port, this is the port number the traffic is coming from. Usually you leave it empty, which is again means any port it comes from, it will be blocked. Destination port is the same thing. And then you have the option to, so if you want incoming traffic blocked, you can drop them. If you want outgoing traffic blocked, you can drop them or accept them. Depends on what kind of a rule you want to set. Then once you're done, you would save the settings and it will be added to your router settings. Next, so as I said, I have two devices, so I have to log in separately in each other. So if I want to change any of my Wi-Fi settings, I can't do it from here. This is more of advanced settings. So I have to separately log into my in my Wi-Fi settings. So this stuff is more basic. So you can see like the status of your Wi-Fi, how long it has been up till, what are the devices that are connected, what is the status. One of the most common Wi-Fi settings that we look into is basically, what kind of what type of Wi-Fi's we have turned on. So 2.4 and 5, the name of my network, if it's visible or not, what kind of a security mode that I have. WPA2 is generally good. We now have WPA3, but a lot of devices don't support WPA3 yet. So that's why I set to WPA2. Here's where you set your network password. If you want to turn some type of radio signals off, again, we talked about different bandwidths. So 2.4 has a longer range, but is a bit slower. 5 gigahertz is faster, but has a smaller range. Yeah, that's about it. That is important, or what we covered in class. If you guys have any questions, please drop it in the live chat, and I will pass this back to David.
Thank you very much for it, Gabe. Anyone got any questions about that fantastic demo there? So we've seen how we kind of control, this is essentially a small home office device. So that device is exactly the same you will find in an office where you sit 10, 15 people. That's exactly what you're going to be doing and looking at. Okay, we can get much more complicated and we can get bigger devices that manage it all. But if you're only opening a small office, yeah, this is the sort of thing you put in. Does bridging two routers make a mesh network? No, I'm not sure if bridging is the right word for it. Bridging basically provides a network connection without it doing much thinking. So it will extend it, but it doesn't provide a mesh network. When you talk about meshes, we normally talk about Wi-Fi meshes. And you can buy mesh devices that talk to each other to provide a full coverage of your systems, rather than basically, an individual Wi-Fi router that has one SSID, a mesh network. They will all have exactly the same SSID. And as you drift around your house or your building, the device will automatically switch over to the strongest signal on the same SSID. So there's no, oh, I need to log off of one and get onto another one. There's simply just a natural flow as you wander around the office. So that's where we tend to use the term mesh from. Right, Majel asked a interesting question about 255.255.255.0. Okay, that is the subnet mask. So don't think of it as a broadcast. If ever you plug a system in and it requests an IP address through DHCP, it uses what's known as the broadcast address for that range. Now, Ragib's example, 192.168.1, the broadcast address is 255. You never allocate a device on 255 because that's the address where you ping out and go, hi, is there a DHCP server out there for me that wants to give you an IP address? So no device ever owns that IP address. And then to make it quite interesting, zeros are not normally used in IP addressing. You can allocate a zero, but if you ever try and allocate a zero on your external IP address, you're likely to get a knock on the door. You're not legally allowed to have an external IP address with a zero in it. You will never get allocated one. Of course, you can fake IP addresses, can't you? Because you can go to your router and say, this is my IP address. You're never allowed to use zeros. Yeah, with the basically the subnet with the 255 host there. So basically what you're doing is your broadcast address is your subnet mask. It is basically your subnet address with 255 as a host. And that's how you get your IP addresses. That's how you scream to everyone and say, hi, can I have an IP address, please? And indeed, we do that for all broadcasting. So if we were broadcasting to ask different questions, yes, we could simply poke it onto 255 and everyone basically has a little listen out and says, is that for me? No, it's not my traffic. I'm not worried about it. Or a DHCP server will put its hand up and go, oh, that's DHCP. That's what I deal with. And it will start replying and it will start our beautiful DORA conversations that we have, isn't it? Some really good questions coming in there. Thank you very much for those. So let's run it up with a conclusion then. Today, we've had some good fun. We've had a lot of good conversations. We've had a lot of fun with Kahoot. Thank you very much. So we kind of listed and described network managing protocols. We talked about those two different types of protocols and what they can do. We've looked at a nice whizzy splash screen of a monitoring solution, didn't we? There are differences between common networks and devices and routers, so we had a little refresh on some of that. And we explained the importance of segmenting networks. So we talked about VLANs, as well as subnet masks for separating networks. And we talked about our DMZs, which is like our super secure area behind our network that basically looks after itself. And you have to step through, another firewall basically to get onto those systems. So that's where we were hyper protective about the communications and the devices in those particular areas. So it kind of runs us to the end of